to get started here. So hello everyone and welcome to ASME's A Day in the Life webinar series brought to you by Engineers for Engineers. I'm Rani Haroon and your host for today's second of a series of 3 webinars that ASME will bring to you this fall. 2 weeks ago, we had a mechanical engineer from Boeing, and today we're going to have an engineer from Aerojet. So what is the purpose of this webinar and what's a day in the life webinar series all about? Well, I'm sure you all wondered at some point what a day in the life of a mechanical engineer working at companies like Boeing, Aerojet, or Tesla would be like. Now you have the chance to find out through this interactive webinar series. Here is how the webinar will work. In a minute or so, I will introduce our special guest speaker of today. But first, let me tell you how this webinar will work. Starting with some housekeeping, all webinar participants are signed in a listen mode only. So please type in any questions you might have in the dialog box on the webinar platform anytime during the webinar. All questions will be answered after the introduction of our guest speaker. In fact, the Q&A session will be an integral part of this webinar. You may ask any kind of questions, whether it's related to the mechanical engineering field, the company, the industry, career-related questions, or any questions related to the speaker's job or position. So for those who are not familiar with how YouTube Live works, and I see that there are already people asking questions here. So, but for those who are not familiar how YouTube Live works, this is essentially where you would type in your questions. So simply type them into the chat box in your YouTube control panel as shown here. One thing to keep in mind is we'll probably get a lot of questions. So we'll do our best to answer as many as we can during this webinar. So let's get us started and introduce you to our guest speaker. Please meet Jess Grant, a project engineer at Aerojet. Jess, at this stage, you have the, at this point you have the stage. So please tell us your story.
Hey everyone, like Randy said here, I'm Jess Grant. I'm currently a project/product engineer at Aerojet Rocketdyne. I'm based out of our site near Seattle, but I've worked with the same company previously in our LA site. The picture they had on there was one of our engines down in LA. I've experienced with 2 different aspects of rocket propulsion, working in these positions, and then as well as my time at the University of Washington, where I graduated with a degree in aerospace engineering. I worked part of a hybrid rocket team there, among a few other things, some industry experience there. But I'm excited to talk to you all today about what it's like working at Aerojet as an aerospace engineer.
Thank you, Jess. So I think at this stage, we are ready to start with our Q&A session. One thing that I want to do is I want to kick this off by asking the first question, if you don't mind, Jess.
Go for it, yeah.
So can you tell us what it's the typical day as a project engineer at Aerojet like?
Yeah, sure. That's probably going to be a bunch of your people's questions here too, so might as well start off with that one. So as a project engineer, at least at this site in Redmond, it means I'm involved in pretty much every aspect of developing chemical propulsion thrusters. My team focuses on in-space propulsion. So we're talking on the order of a few pounds of thrust, depending on satellites, other spacecraft, things that are going into space for small things, not launch vehicles here. And as project engineer, I get to help with every aspect of that along the way. I might be helping with the development project one week, working on talking to the customer and getting the specifications and requirements we need to develop a new engine. Or currently I'm working on a production program. This means we have an engine that we've been using for a long time. We know it works well, but customer wants to order a lot more of those. We got to ramp up and make, a few hundred of those a year. And maybe that's small for some industries, but for rockets, that's a pretty big number compared to most of them. So in that aspect, I'm helping with fabrication of things, helping with assembly, kind of corralling the different engines we're making through test phases. We want to hot fire everything, make sure they're working well. I'm responsible for writing up those test procedures and working with test engineers to complete the tests, and then looking at the data that comes back afterwards, deciding, okay, this is good, we can move ahead. Hey, that looks a little weird. What do we do with that? Maybe we should just look a little closer. Maybe we need to do a new engine. And then following all the way through to delivery of the products, which then involves shipping it to the customer and handling any kind of support we need to give them after they've received our products, which, once we ship it to them, it's kind of hands off, but a lot of times they have questions, and when you're talking rocket propulsion, sometimes it comes up and they might want to help, and we're happy to help, make sure their satellite's not going to deorbit early or something like that. But I think I kind of hit on most aspects over there. I don't know if you have any follow-ups on that, Ronnie.
Okay, great. Thank you, Jess, for that. So let me, I guess, go through the list of questions here. First one is from Debashish. He's a mechanical engineer, undergraduate student.
Okay.
He wants to be an aerospace engineer, and he's wondering, how does he prepare himself for his higher study and career?
Okay, that's kind of probably a lot of answers I could give to that, but I'll focus on a couple just for the sake of time here. But as a mechanical engineer wanting to move into the aerospace field, it's pretty close. Some of you may already know this, but maybe some of you don't realize you don't have to have an aerospace engineering degree to work in aerospace engineering. Half the people at the company that I work at are mechanical engineers or chemical, whatever it is. But the big thing in undergrad is to find opportunities to use your mechanical engineering experience, but focusing it on aerospace applications. And that's kind of what I was able to do. I mentioned I interned previously at the same company at a different site, and that was in college. Most aerospace companies they love to hire mechanical engineering interns, and it might even be a mechanical engineering position. But if you're doing it at an aerospace company working on aerospace products, that's even more important than taking some of the classes in an aerospace department, which can be another good avenue too. I know at UW, where I graduated from, a lot of people did that. They were a mechanical engineering major and then took a few classes in the aero department. A lot of people got involved with our rocket team. That's a great way to do it too, because having the combination of aerospace engineers and mechanical engineers, they both know a lot about different things, and bringing that information together is a good way to get a good rocket or whatever aerospace product you might be working on. So I think it's definitely possible to get involved in aerospace opportunities early on, even while you're in college, and then that can lead to maybe a rocket team leads to an internship, which then leads to a full-time position at an aerospace company, and then I guess you have a career in aerospace then by then.
Great, thanks, Jess. Question related to software that you may be using. So a question here from Ruthie. Which CAD software is used by major aircraft manufacturers?
Okay, so as a project engineer, I don't directly get to use any CAD, but I do work with a lot of designers and others who do, and I know I have friends at other companies too that do a lot of it, so I can kind of answer that. I think the main packages are, like Boeing, for example, uses a lot of CATIA. I know of some other smaller companies that use that too. At Aerojet, we use right now mostly Creo, which is a similar level of software, but just a different company that makes it. On CATIA, that's a nice one to get going with, because SolidWorks is made by the same company, and I know many of you who are in undergrad still are probably learning SolidWorks right now. That was what I went through with my classes. We didn't have any other options. And I think it's kind of an addition here on which CAD packages are used by which aerospace companies. It's less an issue of which specific CAD you know, as much as it is if you know how to use CAD in general and how to apply different design theories, and have some idea that you want to create and know how to get that from just an idea to being in the CAD software and being a 3D model and then getting it down on paper so you guys in the shop can actually go and make it. And I think a lot of people I've talked to have expressed the same thought, that if you have, maybe you're expert in Creo and then go somewhere else and they want you to use MX. That's one of the other big ones that a lot of companies use. It's pretty transferable. It might be a couple of days of learning some of the details of how they work, but the general theories kind of apply.
Okay. Thanks, Jess. Question here from Kathy. What is your favorite part of your job?
This is always a good question.
Mhm.
So again, I have probably more than one answer I could give for this, but I think one of the best things right now as a relatively new member of the team at this site anyway is just the people I get to work with. And that's partly because of the role I'm in as a project engineer. I, by nature, get to work with a lot of different people versus some disciplines maybe a little more focused on smaller teams. And I have that same smaller team, but I'm always reaching out to all these other people. The other day I had to go talk to a structural analyst, and I know the basics of structural engineering and how fracture mechanics, all that kind of stuff, but I'm not an expert. So I had to go find out who to talk to, go talk to him and get information. And everyone at this company anyway is very open with answering questions, even about things that are not related to what they're working on. I had another thing I was working on. We had an issue with a part, and I learned that somewhat a different program making a different product had a similar problem like 5 years ago, and I found one of the guys who worked on it, and he pointed me to a few other people, and they're all like, "Oh yeah, this is what we did. Here's the information on it. Let me know if I can help with fixing your part and all that." And it's a really cool collaborative environment that I had that in college, but I wasn't sure how much that would carry over to industry. And fortunately, at least to this company, I think that it did well. So getting to work with all these people who know way more than I do and having them as accessible to learn more so I can improve my engineering skills and get stuff done is really cool.
Great, thank you. Question here from Mallory. Do you see a future for the Aerospike engine in the space launch industry?
Aerospace. It's a fun question. I think I'm not too knowledgeable about the aerospike, but I at least know what it is, which is probably more than some. And I have to say at this point, I don't think there's major applications, at least in the near term, like 10, 15-year range, just because a lot of companies that have tried to do it they've developed the technology. Aerojet Rocketdyne, for one, we did a linear aerospike. Look that one up. It looks really cool. They had a big one in LA that we could look at. And it's, in theory, you get such great performance out of those engines, but they're just so hard to manufacture. You have to make so many trades in making it possible that you end up kind of negating any of your benefits you had from the performance. And I know like Firefly Aerospace, they're kind of in the news lately is partnering with our company. Back before they paused for a while, they were planning to do an aerospec engine, and that didn't work. They lost funding and kind of went away for a while. Now they're back, but they're just doing traditional liquid engines and not really worrying about the aerospec. So I don't think so, but I do think it's a cool engine. So hopefully I'm wrong.
Thank you. Thank you, Jess. Great question here from Hamid, who's wondering what is the work culture like at Aerojet? So if you could walk us through how it was as you joined the company and share basically your story and what were your first impression and what has, and if it has changed over time.
Yeah, you mean work culture kind of is in like the environment and that kind of thing.
Yeah.
Yeah, I mentioned a little bit of this already, I think, but it was a little different from what I expected coming out of college. And this is speaking to more to when I first interned there. And I didn't really know what to expect. I mean, okay, you're going to a company and in LA we have, I don't know, 2,000 or 3,000 people working there. It's way bigger than my college rocket team, which is really the only experience I'd had before that, which is 50 to 100 people. But like I mentioned, everyone there is very willing when they have the time to help out with whatever it is you need. And I talked about technical a little bit, but even when I first started at the company, and when I started again at this site, which was a different team, everyone was great about getting me on board and answering any questions I had. And they have a very good, at least at Aerojet, a good setup with how when you start, you have your manager and your team and all that, like every company does. They also assign you a mentor, which I know other companies do. And that's very helpful as someone who can kind of guide you along the first steps in just getting to know the company, like which building is this conference room in? I've never been there before. And a lot of the people around are very friendly and helpful with anything. So you have your mentor, you don't even need them really, you can just talk to anyone else. But the mentor's good about helping you with that kind of stuff, and then also helping you come up with daily tasks you can work on. Because when you first start, you might have an assignment on some program. Say, okay, we got to do a new test procedure for this thing. And you know, a test procedure, but I didn't know how to write one. And they were good about balancing, giving me input on how I can get that done and what I need to look into and research before I can write it, while not just doing it for me, which was really cool to get ownership of something that's actually going to be used in production hardware at some point, and then eventually go into space. Even in my first couple months here, it's like that. If that kind of answered the question.
Yep, thank you. The question here from Jake. Did you begin at Aerojet as a project engineer, or did you gain experience with each aspect of your job, manufacturing, testing, analysis, in a former position?
Oh, that's a good question. So I started as an intern in the same position, but it was at a different site. So it was like half the work was pretty different, but it's the same job description anyway. And starting here, I did start in this project role, but you hit on a little bit of getting experience in different areas. This is actually why I was very happy to be able to get this position coming out of college. Is I got to get all that experience working with all these different teams and people at the company. I'm not a manufacturing engineer. I don't do that for 40 hours a week, but a good 5, 10, 15 hours of my week is meeting with and solving problems with other manufacturing engineers and quality engineers and test engineers and whatever areas I'm working on at the time. So it's this role as a project engineer is a very good way for me to get kind of the broad experience of all these different areas. And I may not want to be a project engineer in 5 years, but because I am now, I'll know kind of what all the other options are, and I'll be able to say, oh, manufacturing engineering was really cool. I kind of want to do that full time, or maybe I hated it. So this project engineering was really cool to do it to get all that different experience.
Great, thank you. Question from Kathy. What do you find most challenging about your job?
Personally, I think the most challenging part, at least right now, as I'm still relatively new compared to a lot of the other people at the company, is finding how to ask questions of people. During my internship, I realized, okay, I need to be better about asking questions when I have something I'm stuck on, or if I don't know how to move ahead with some project, I need to go ask people. I realize that, but it's still hard to find the balance of, okay, I know this person has the answer I want, but they're in meetings all day and I can't ask my mentor because, they're offsite visiting a supplier or something. So personally, I'll kind of go down routes on some task I need to do, and I'll get stuck and I'll realize that I need someone else to give me input there. But sometimes it'll just kind of be a holding place. I'm still trying to figure out how to balance getting things done in an efficient manner and not just sitting around, waiting for people to be available so I can ask them questions. And combining that with, looking up things on my own, getting better at doing that too, because certain times resources might be available and you might have a question that you can find it on the internal server somewhere, or you're just Googling it. But other times it might be more efficient if you go ask someone specifically your problem and they've dealt with the exact same thing before. That's kind of the current challenge, I think, for me.
Great, thank you, Jess. Question from Abdul. What type of skills do you expect from a fresher while recruiting?
You like a freshman? Is that what the question was?
Yeah, so someone basically who's, who just finished college.
Okay, I can recently graduate, yeah.
You're recruiting this, you're interviewing that person. So what would be looking for? What are the skills you would be looking for?
Okay, yeah. I think I just went through this myself on the end of being a recent graduate, but I talked a good bit with my manager and some of the other people that are involved more in the hiring. And I was involved in hiring separately for a different project in college. But I think the big thing for engineering students is get some kind of hands-on experience before you graduate. Obviously, the default is an internship, but not everyone can get an internship. Sometimes they can be very competitive, especially if you need to stay in the area or whatever, the different factors going on. But there's always some way you can get involved. For me, the big thing was getting involved in my rocket team. That, while giving me a little bit of the technical skills that were useful, and I built a rocket and now I'm building rocket engines, it honestly didn't carry over that much technically because of the different scale and scope of what we were building versus what we build at the company now. But what it did give me is the experience working on a team and working on a project together that had, to go from start to finish. You got to define the project, figure out how you're going to build it, fix all the problems along the way, test it, rebuild it when your test blows up. build it again, and then go to, in our case, a competition, whatever the final goal is. And I think that experience of being in there and having to solve engineering problems as they came up, they're nothing you learn about in classes. It's like, your O-ring breaks. Like, no one tells you how to do that in an engineering class, but you figure out those kinds of skills, and generally what that teaches you is just how to solve problems. And classes do a good amount of one side of that, but they're more focused, of course, academically, whereas the hands-on engineering problem solving, I think, is the biggest thing that most, at least aerospace companies, look for when they're hiring new engineers. If you have that experience and someone else, they had a 4.0 GPA, they went through, they did some research and stuff, but not a whole lot of hands-on team experience, they might go for the person with the lower GPA that actually has had that experience, because they know that they're a little more proven in being able to work in the kind of environment that a typical aerospace company would be.
Okay, great. Thank you, Jess. Another question here from Root Week, actually a very good question, who's wondering if typically Aerojet does work, does collaborate with SpaceX or NASA, and if that's the case, have you ever been involved in such a project?
Yeah, that's a good question. I haven't personally been involved in any of, like, not with those two specific companies. As a rocket engine manufacturer, everything we build goes to some customer at some point. So I am involved with a customer that I'm working on. I won't say their name, but it's not one of those. But I know NASA, for example, that's the easy one because they're all public about things. A ton of our products go on NASA spacecraft and launch vehicles and all of that kind of thing. If you just watch the Boeing's, the Starliner abort test, I think it was yesterday morning they did that. Look it up, it's a cool video. A lot of, actually, all of the propulsion on that system was developed by Aerojet. A good portion of it was done in Redmond here. And I didn't work personally on that, but the company did, and that's, Boeing's building that, but they're building it for NASA to use. So I would call it a NASA product. In addition to that too, we've done the engines for the recent Mars lander. I know Voyager was in the news again. Voyager 2, I think, just got into interstellar space. That's a lot of the thrusters on that are keeping it going and making sure it doesn't, get out of the way of communication range. Those thrusters were built in Redmond back in the 70s, but we're still building similar versions of those, and I get to work on those now. And hopefully before too long, I'll actually have worked on something that directly went into space, but everything in this industry is kind of slow. So, you might finish a product and it takes a couple of years to get there, but a ton of our stuff is collaborating with NASA and other companies like that.
Great. Thank you, Jess. Another question from Kathy. What is the work-life balance like at Aerojet?
I like this question because I think there is kind of a difference even within the aerospace industry. On one hand, you have some of the newer startup tech companies that are maybe moving faster, doing more cool stuff. One of the downsides to that is maybe a worse off work-life balance. And this is just a personal preference. If you like it one way or the other, I have no problem with it. But I wanted to have a fair amount of work-life balance. I wanted to work 40, 50 hours a week and then have some time off and all that. And Aero just provided that really well for me. I know like Boeing's another one that does, they're good about that kind of thing. But here in Redmond, and actually at most of our sites now, we are on the 980 schedule. This is kind of a fun fact, I guess, but that just means that we work 9 hours every day, every other Friday, and we don't work at all. So I get a 3-day weekend every 2 weeks. And I thought that was cool before I started. Now that I'm living that, I don't know how I'd be able to give it up. So I think at Aerojet, it's a really good balance. Something might happen and maybe a customer calls you and something's on orbit and they need to fix it ASAP. Yeah, you might want to answer that call and come in on a weekend day. But in general, it's a very good balance here. I think people respect that you have your work and you have a life outside of that. You maybe have family, things like that. You're not expected to give that kind of thing up.
Okay. And thank you. Just follow-up question on that. So what drew you to Aerojet specifically?
That's a good question too. So since probably sophomore year of high school, maybe earlier, I knew I wanted to work in the space industry, not just aerospace, space specifically. And Aerojet was one of the companies on my radar. Is they build rocket engines. Like, that's pretty much as cool as you can get, in my opinion. As an engineer, nothing's cooler than a rocket engine. And obviously, there's a few other companies that do that, especially nowadays. But Aerojet, I was had the experience as an intern there, and that was I applied a lot of other places too, and that was the one I ended up getting. But I was very grateful for that because it exposed me to the company and kind of gave me a chance to evaluate. It's like a long interview, you know, for the company and you both ways. Um, and it was really satisfying to work on rocket engines that are actually going to go to space someday. Again, there's other companies that do that too, but in combination with that, it was a great work environment. I already talked about work-life balance. Everyone in the company is super helpful if you need them to be. Lots of great people to work with, and again, that good work-life balance and kind of just all the factors around there combined. And additionally, I was able to get into a position here in Redmond, which is I'm from kind of around here, so there's another plus to stay local. There's not a ton of rocket engine companies in Seattle. There's a couple, but this is one of the ones that worked out well. So happy to have ended up here.
Great, thank you, Jess. So question, very good question from Justin here. So how realistic is it to switch careers to something like Aerojet as a mechanical engineer with 13 years of unrelated oil and gas experience without going back to school?
Did he say like what kind of unrelated experience that would be?
So basically he has a background, so he's a mechanical engineer, but in a different industry, right? So I was wondering how hard would it be,
okay, yeah,
would it be to switch,
like to pivot over
without going back to school?
Yeah, I think at this company, and I think this would apply to most aerospace companies as well, they don't care too much about if you're working on the same products they have. Like say, a little more closely, let's say you're working at Boeing and you're working on like the wing structure or something as a mechanical engineer. That could still be very valuable experience to Aerojet or one of these other space rocket companies. I think the main factor is having that engineering degree and having some engineering experience, even if it's in a different kind of field. A lot of our employees are also quality engineers and manufacturing engineers. Most of those people that didn't come straight out of college worked in some other industry. They didn't usually come from, you know, like they went to SpaceX and they came here. They worked at, I worked in, I think it was some kind of pharmaceuticals, and now he's a quality engineer on rocket hardware. So I think it's very easy to pivot as long as you have engineering experience. And it kind of goes back to what I was saying earlier with having the engineering problem solving experience. If I know how to problem solve I don't know, a car engine, I know how to do that on a rocket engine too, even if it's a very different kind of environment. I still have those core skills that are the most important part, I think. And I think also too, it's a lot of these companies, they kind of like having the different experience because if everyone you hired has worked on rocket engines and that's it, they know how that works. But there's a lot of biases that come into that with having only that context. So I think having experience in a different industry can, depending on the position, actually put you at an advantage over someone who's been in the industry for a long time. And the exception is, you know, if you're hiring like a technical expert or something, okay, yeah, you probably should be doing the same thing for 30 years of your career. But in general, I think it's very easy to pivot over to this industry from somewhere else.
Great, thank you, Jess. So question here from Ethan. So we're going to answer your question, Ethan, so don't worry about that. So what satellite do your rocket systems focus on?
Sorry, could you repeat that one again? It kind of stuttered there a little bit, the recording.
Okay. So what satellite do your rocket propulsion systems focus on? LEO, GEO?
Oh, okay.
Do you ever work with anyone involved with satellite reboosting?
Yeah, so in Redmond, we do all in-space stuff I mentioned a little bit earlier. That means it's almost 100% going on satellites. Sometimes like reaction control thrusters, that kind of thing for launch vehicles, but mostly satellites. So yeah, changing orbits, all that kind of stuff. If there's a satellite up there, there's a very good chance that we built the thruster that's letting it change that orbit or correct an orbit or whatever it is. At Aerojet Rocketdyne as a company, they do other types of propulsion as well. I didn't handle this too much yet, so I'll go into a little bit. Here's in space in LA, they focus a lot more on large booster type engines. Space Shuttle main engine, kind of the classic one, and then RS-25 is the recent one that's been in the news too, as they're rating it up to the NASA's SLS core stage. They built those large engines there, and that's going to be lifting it from, you know, ground level on Earth up to, well, eventually up to the lunar orbit, I think. And then also a lot of other types of applications of propulsion, but focusing on space type stuff, it's kind of the whole range of launch vehicle to tiny in space propulsions on the order of some of our stuff goes down to, say half a pound of thrust. Big engines in LA up to 500,000 pounds of thrust. So it's quite a range in this company.
All right, thank you, Jess. Question here from Hamid. What analysis packages do you use? Do you do multi-phase simulation? You want you to tell us more about Aerojet simulation tool.
So this one for CAD, I was a little bit more able to answer. I'm less familiar with our simulation stuff, as I'm not in that position, but I know we do a lot of FEA for our structural analysis. I think, I don't know if it's exclusively, but at least some AND systems involved there. And then there ends up being, especially with the larger engines, I worked on booster engines previously at the company, lots of CFD work, so that kind of FEA. And I don't know specifically what software packages we use, but there's a lot of that goes into it. I was working on turbo machinery, and for those of you familiar with turbo pumps and that lot of things, there's lots of complex fluid dynamics going on all over there with all that rotating machinery. So there's a lot of analysis. Sorry, I can't answer that one a little more clearly, but hopefully that helps a little.
No problem. Thank you, Jess. A question here from Mallory. How has additive manufacturing impacted the production side of Aerojet? What are your thoughts on using this kind of technology for manufacturing?
I'm surprised we didn't get this one sooner. Additive manufacturing is super cool to me. I don't currently work on much with it, but I've done some research on it, did like an extra class on it, that kind of thing. I think there's huge applications for it. At Aerojet specifically, I know we have some work going on, some stuff I can't talk as much about, in replacing different components with additively manufactured versions of those. I know on some of the large engines, they're able to reduce part counts on the order of, hundreds of percents, which reduces costs by a good amount and speeds things up and all that. And then on some of the smaller applications we're doing too, I know we've at least looked into it for a lot of applications. It's such a great technology, mostly because it allows you to change your designs and not, okay, you can make it faster or cheaper, whatever, that's all good. The main thing I think though, and I see it as benefiting the industry, is it allows you to take some part that does some function, and if you're able to completely rethink how you're getting to that function. I think that's one of the challenges with it, is a lot of times companies will say, oh, we have this part, we want to make it with a 3D printer so it's cheaper. And they'll do it, but it'll just be the same thing, but 3D printed. When really the better approach to actually save money and really achieve that innovation is to take what you have and rethink it from the start. Okay, we don't have these constraints. We don't have to have this edge be, a square corner, because we don't have to mill it. We can print it. We can do whatever we want. And I talked about turbo machinery a little bit earlier. That's another big application, I think, because with turbo machinery, you have all these parts rotating at hundreds of thousands of RPMs, and high stresses, high thermal stresses, because they're rocket engines, all of this going on. And AM lets you design parts such that it can handle all of that at a much lower weight, which when you're launching a rocket to space, weight matters way more than anything else. And of course, there's a lot of the smaller startups now that's kind of their thing, is using AM to make these rocket engines. I know, I think Relativity is the big one. I'm sure you've heard of them. They're trying to do a fully 3D printed rocket engine. As far as I know, they're getting there pretty close, and I think that'll be a big impact on the industry and that kind of small launch vehicle application, just because they'll be able to get much higher performance for that same lower price on those rockets that they're building.
Great, thank you, Jess. Another question, very good question from Rutwig here. What steps are involved in testing a newly built rocket engine, and where is it tested?
Oh yeah, that's a fun question. So again, that kind of depends a little bit on which type and what size of engine you're testing. The big ones, like the large booster engines, kind of like what I was working on previously in LA, they mostly send those to Stennis Space Center, which is a NASA facility in, I believe, Louisiana, somewhere over there. Yeah, I think that's right. And or Mississippi or something like that. And they will assemble them all the way, truck them over there, and the the main cool test anyway is the hot fire. Any engine, as far as I know, any engine that gets shipped from any company is hot fired at least once, just to make sure everything's all in the clear. So that involves fueling up whatever facility tanks you have and hooking up the engine to everything. The interesting thing is there's usually a lot more wires and cables running out of a engine you're testing than just the engine you put on like the space shuttle or your spacecraft, because when you're on the test stand, that's the opportunity for you to get all that extra data on whatever's happening inside there. For smaller engines, like the ones I get to work on, it's similar with the static testing, but obviously they're smaller, so it's a little easier to do. We do a good majority of those here on site. We have a very well-equipped test lab that can, make a thing in the shop, bring it over to the test lab, fire it, bring it back, and then do whatever we need to after that and ship it to the customer. And aside from that, there's lots of little component tests that happen along the way. Say you have a valve that's at least one valve in every rocket engine. There's lots of those all over. You're going to want to test that for its what kind of fluid flow rate you're getting, opening time, that kind of thing. You'll test all that and then put that together with all the other components, get your assembled rocket engine, run that through maybe some more component level tests while it's in assembly, and then hot fire it. But there's a ton of testing involved just in any level of rocket propulsion. It depends a little bit, but whatever size engine it is, you're going to have dozens of tests on any given engine, I think.
Right, thank you. Just a follow-up question on that. How much does it take to, how much time does it take to build a rocket engine?
Okay, that's another one of where it depends, I think. On these large booster engines, it's on the order of several months. Smaller engines, I won't give specifics, but again, it can be down to more like a few months, but I don't think any of these rocket engines, at least what I've been involved in, take less than a few months, just because there's so many rigorous requirements that you have to go through, and like you have to go through like component testing, and you get them from a supplier, you got to test these things, then you have to assemble it, build it. That takes several more weeks. You got to go through the full test while it's assembled, check all of that stuff out, and then pack it up and ship it. And all those steps, even when they're relatively simple, there's just so many of them that it takes at least a few months for small ones, and some of the bigger engines can take closer to a year to build. So it's quite a process, which I think is true of most things in the aerospace industry, even if it's not rocket engines.
Great, thank you, Jess. Question here from Debashi. So he's wondering how he can get an internship in an aerospace company while he's doing his MS or his master in aerospace engineering.
It's as far as I know, unless you have interesting factors going on, it's the same as it would be for an undergrad. Basically, you go to whatever company it is, apply online, do all that stuff. Tons of tips I could give them, like resume writing and all that, but I don't want to get into all that today. But the other thing too is I talked about opportunities earlier where you can get hands-on engineering experience, and I think another way to improve your chances of getting an internship at whatever company it is that you're really pushing to get a job at is to find those connections with people that work there. Even if it's just like looking up someone on LinkedIn and say, hey, like, can we talk about this company? You're not going to go in and say, hey, can you give me a job? But making those connections. And for me, some of those connections came from working on the rocket team. I've met people that were seniors when I was a freshman, and some of them I was able to maintain relationships with and just kind of see where they went, what companies went to, and then, hey, this guy I knew 2 years ago works at Aerojet now. I should talk to him and see what's going on there and get some intel. I think kind of having a lot of those going on and just keeping relationships with the people that you meet that they might be friends, it might just be people you happen to work with one time. LinkedIn is obviously great for that. You can leverage those to kind of get some more insider information on different companies, like when they're hiring. Like, oh, hey, my team's hiring. I remember we talked about this a while ago. You should apply for this job. I can pass your resume on to the manager. Just that kind of thing. That kind of answers the question.
Right, thank you, Jess. Question from Sheila, what is your opinion on folding wings for an aircraft?
Ooh, opinion. Uh, well, I don't know exactly which way you meant the question, but I mean the new 777X that Boeing's almost finished with, I hope. It's got those folding wingtips. And it's qualified to fly by the FAA and everywhere, which maybe nowadays is a hotter issue, but they made it work. And I think in general, it's a lot more complicated to get things like that to work. But if you can make it happen, it can be a big advantage to getting that example of aircraft getting longer wings, which gives you much higher efficiencies and keep you flying longer on the same amount of fuel. I'm not sure exactly if that was what you meant by that question. Maybe you can follow up and keep an eye out for that.
Yes,
Uh,
that question, yeah, was from Sheila. So hopefully that answers her
yeah,
question.
send another question if not, Sheila.
Yeah. Let's move on. So, another question from Justin, who's wondering if there is any online forum where he can make industry connections. So obviously there is LinkedIn, but is there something that's more specific to the aerospace industry where he can connect and meet other engineers?
Honestly, LinkedIn's probably the best bet. It's not always the best for that kind of thing, but I'm not aware of anything else. If anyone hears of anything, let me know. Um, I think LinkedIn is kind of a big network and tool that you can use, but it is you kind of have to figure out how to use it well to be able to use it as an opportunity to make connections with people. And some people just go on LinkedIn and they add anyone that's works at a company that they want to work at, and it's like, okay, have some kind of personal relationship with that person. At least I've met them once and say, and then add them and say, hey, I met you at this conference, blah blah blah. Um, so I think there's not really an online forum for that, but I think there are lots of opportunities for you to meet people that then can then use it on LinkedIn and actually make LinkedIn useful with going to AAA or ASME conferences or research symposiums, but that kind of thing. There's lots of ways to meet people in person and then carry that over to an online on LinkedIn.
Thanks, Jess. What is the most interesting project you worked on as a project engineer so far at Aerojet?
Most interesting. I'll pick one. Maybe it's something else. I got to think about that for a little bit. But when I interned there during college, I was working on turbo machinery for a large engine, and that was really interesting as a aerospace engineer. I'd never really learned much about turbo machinery. I know some mechanical engineers can focus on that, but some schools don't even have a class or anything. So it's brand new to me. And working on that big of a component of or system of a system was really interesting just because there's so much going on, and I was working on the small parts that are part of this assembly, part of this bigger assembly, part of this system, part of this rocket engine. Kind of the whole level there was very different from what I'd done before, and that it was just one small piece of a big thing. And then working on turbo machinery is crazy anyway, just because there's so much going on. Everything's spinning at 100,000 RPMs, and like everything wants to fly apart. And then it's put in a rocket engine, so everything's getting hot. Half the stuff's getting cold because you have cryogenic propellants. You have to make sure those things are mixing, and it's just there's all these factors going on. And obviously, I wasn't working on like making all of that work together. I was only working on a small part of it, but having that small part in the context of this big, complicated machine was really cool.
Okay, great, thank you. Jess, another question from Debashish. Is there scope for doing projects of self-interest besides the project of the company? So basically, can you do some kind do you have the freedom, I guess, or the flexibility to do your own project besides the one that Aerojet?
That's an interesting question. I think this answer will kind of speak to at least the other major big companies. I think Boeing and those kinds of things. I wouldn't say you have the freedom to work on whatever you want. It is a job, and they're paying you to, make a product and get it through and ship it to the customer. But I think to, I guess, mitigate that a little bit, because there's not a whole lot of freedom in that. There is freedom more in what your interests are, and this depends a little bit more on your specific manager. But I've been fortunate to have great managers so far, and they if a manager is a good manager, they recognize that an employee will be more productive and get more done when they're happy with what they're working on, right? Fortunately for me, I'm happy with rocket engines, so it's easy. But if you're working on some project and say you want to go work on maybe something that's focusing a little bit more on the structural development of some part, and so far you haven't gotten that experience, in general, your manager is going to be okay. He'll keep an eye out for programs that are coming down the line and projects like, hey, we're going to make this new rocket engine and we want to change this structure on it, and we need a project engineer to support that. So if you want to work on that project with these guys on structural, this might be a good opportunity. And I think that's kind of a good way to get more specific experiences and maybe have more interesting projects if you're not as excited about what it is you're primarily working on. And part of that is on the employee too. I think it's important to voice your interests and any concerns you might have to your manager. A lot of people, I think, don't learn that right away, but I think communication in two ways can be very valuable. And it's, as a new engineer coming out of college, I mean, sometimes it's kind of intimidating. You don't want to be like, hey, I want to work on something else. But again, it's managers understand that you'll be happier if you're working on something that you're interested in. And I think usually there's opportunities to get on different projects and programs that are maybe a different variety or different things you can work on, even if it's not the actual freedom to work on like a personal project. But then maybe, yeah, I think in the industry it's pretty hard to have free time for that kind of thing. So everything is, I think, is built to specific programs and budgets are very closely watched. That's kind of one of maybe the downsides of the aerospace industry. But
got it. Thank you, Jess. A question from Mallory: does Aerojet provide personal growth opportunities for its employees? If so, what kind of opportunities?
They're pretty good about it, I think, at least in what I've seen so far. There's other companies maybe better, but they've been making a noticeable effort even in the time I've been there to improve development opportunities for the employees. They recently, I think it's starting next year, so recently they're doing a new rotation program, which I know other companies do, and it's a cool opportunity for someone who's maybe been there a couple of years and is interested in a leadership role, and it kind of sends them through different areas of the company and has them work as different types of engineers for like 6 months at a time. And then at the end of it, their idea is that you would go back to one of those groups and have all the experience in all of them and then be more qualified to be, say, a manager than someone who's just been in one position the whole time. But I think things like that, and there's kind of the general focus, like I mentioned a little bit, of managers working with you to find out what your career goals are and what kind of interests you have, and then working to give you opportunities to develop those so that you can then move up in whatever direction it is. Maybe it's people management and that kind of leadership thing, or maybe it's becoming a technical subject matter expert or program manager, whatever it is. I think they do a pretty good job at it, and more importantly, they're working to improve it, which I appreciate.
Okay, great. Thank you, Jess. Another question from Ludwig: what are the major factors that can cause a rocket engine to fail mid-flight, and how does a company tackle those problems?
Oh man, well, when you get to a bigger engine, especially, there's so many things that can go wrong. It's not, the problem isn't keeping it from failing. The problem is like getting it to work, because the rocket engine really wants to fail because there's so many extreme environments happening. I think the big thing on larger rocket engines is oftentimes it is the turbopumps. I mentioned high rotation rates and that kind of thing before. All it takes is one little defect somewhere. Say you have a turbine rotor blade that has maybe the manufacturer of the original material in some other country had some tiny defect along the line, and it got cut into a piece of stock, and then we bought it from someone else and then made it into this whatever shape we needed, and then our turbo was spinning a little faster than we designed for, and then that little tip something breaks off, and then you have a loose object in there, and then everything just cascades from that, and then you use engines and that kind of thing. Um, I think it's a pretty general question, but there's a lot of things that can go wrong, and that's why we do all the rigorous testing that I talked about earlier. Is we have to make sure these things are going to work, and that's, to me, actually what's kind of cool about this industry is that everything has to be perfect, because as soon as you start a rocket engine, either from the surface of the Earth or a spacecraft in orbit or whatever it is, there's no going back from it. You start that engine and it's got to work perfectly until it's done burning, and if not, you're risking at best millions of dollars of hardware and launch costs, and at worst, human lives. And I think that's it makes some things more challenging, and sometimes you do have to be more patient in this industry, because if you have a rocket engine, you want to make sure it's going to work. It's going to take years for you to develop it and qualify it and say, oh yeah, this is okay to use on this spacecraft. But again, that's what makes it also very cool to work in, because it's just a rigorous environment that everything has to be tested and thought out so thoroughly. There can't be any small imperfections, just because the risk of anything happening is very high.
Yeah, makes sense. Thank you. Another very good question from Justin. So, what are the drawbacks of working in the space industry? So it is true that so far I think we've been talking a lot about the benefits and the great things about that industry. So what are the drawbacks?
Yeah, a good segue here. I think I kind of finished answering that last question on this actually. You do have to be kind of patient if you want to see things all the way through. I'm in a role where I do get involved in all the different phases of development of a new product, but aerospace in general, and especially space and rocket propulsion, things move very slowly. Even with some of these startups and all that, they're moving at startup speeds, which is way faster than the big corporate company like us. But they're still taking several years, which is, in other industries, that'd be unheard of. If you're in software, for example, you have some product you're selling and you want to make a new version of it, you can be working on it for a week or two and have it out. And if stuff's happening and not working, you can just fix it on the spot. It's fine. In aerospace, that's never the case because the stakes are so much higher. And that's not saying that other areas it's less important job or anything like that. It's just a different set of requirements that we have. But I think it does require a lot of patience if you care a lot about seeing things all the way through, which I think most of us as engineers, that is important. And this goes for like Boeing and aircraft and all those other companies too. It takes a long time to develop a complex system and make sure every component is working perfectly, make sure the system is working perfectly, and then qualify it and do all the tests you need and convince all the regulatory authorities and the customer and everyone that it's going to work as you need it to, and then eventually get it to its application. I think that's just one, but I think that's the major one in the aerospace industry.
Yeah, that makes sense. How about politics, red tape?
Oh yeah, I guess the politics, that's, thanks for mentioning that. With especially the space industry, obviously, that's another big thing. That's a downside of working for, say, NASA. They're a government agency, which has a lot of benefits too. But the downside is that every 4 years we get a new president and their budget changes, and we're going to the moon right now, but then next year maybe we're going to be going back to Mars, and then another 8 years we're going back to the moon, and then we never get anywhere. So it's easy to get cynical, I think, but it is important to maintain the focus. Okay, the bigger picture goal is like we're getting people to space somewhere, even if it takes longer than it should. But dealing with the politics that can happen along the way, and even as a employee of a private company, we still, I mentioned before, most of our customers are other companies. A lot of them are NASA and other government agencies, and it's the same kind of thing where they might say, "Oh, hey, we want these engines for the satellite," and then 6 months into developing the new engine, they're like, "Oh, our program got canceled, so now we don't have money to pay you, so stop working on it." And then sometimes that kind of sucks. And you learn stuff along the way, but still, it would have been nice to follow your stuff through all the way. And then red tape within corporate cultures, that's sometimes an issue too. I don't think that's exclusive to aerospace engineering, but maybe a little more prevalent there. And it goes back to the same thing with the stakes being so much higher. whether it's an airplane that's carrying 300 people or a rocket that's sending a few people up to the moon. It's, if anything goes wrong, it's the worst that can happen. So everything has to be perfect, and it takes forever to get there. And there's lots of requirements that have to be met, and you have to demonstrate that you met those. So there's a lot of documentation and stuff along the way saying, oh, hey, we have this requirement. Yeah, we're good there. And maybe other industries, you could just ship it and it'd be good, and you can afford a little bit more risk. But just because the stakes are so higher in aerospace, it makes things take a lot more work sometimes.
Great, thank you, Jess. So we're, I think, yeah, it looks like we're approaching the top of the hour. So we're just gonna go through maybe a couple more questions and we'll wrap things up. So I don't think we've talked about this yet, and I think it's kind of important for a lot of folks here. What about the interview process?
So yeah.
Yeah. Can you talk to us about that a little bit more?
Yeah. And I guess I was kind of lucky. I interviewed for 2 different positions because I interned previously, and then I went this full-time position. And I'll just talk to Aerojet specifically because it does vary quite a bit in different companies. But for internships at the company, you apply online, do all that, and if a recruiter or hiring manager likes your application, the recruiter will set up a call with you, and you'll spend usually 30-ish minutes just on a phone interview with the manager, who was the one making the hiring decision, and they're the one who you'll be working with over the summer too. So it's a good chance to evaluate them. And that's the only real step in an internship. So I was kind of surprised. It was a fairly smooth process. And I'll talk about questions in interviews in a second. For the full-time position, it was the same kind of thing. I applied and heard back from the recruiter, hey, this manager wants to interview you. Had a phone conversation with them. And then after that, there was another step, and that was a on-site presentation. Obviously much more stressful than just a phone call. I spent at least a few days making a presentation that I thought was perfect. They must have liked it enough anyway. And it was probably half to a little more of a whole day where I was on site, met a manager, and presented to, I think, around 7 or 8 people. It was him and a couple others from the team I'm now on, and then some other more experienced members of the company, and then at least one other manager from a different team, which I think was just kind of if we don't want this guy, maybe you do. So I ended up presenting on a project that I'd worked on with my rocket team in college, and spent probably 30 to 45 minutes talking with them, going through the presentation. They're asking questions along the way, all of that. And then after that, they had a few more questions that were kind of your typical interview questions. And then, of course, I got to ask them a lot of questions I wanted to. And then the other half of that day on site was just touring around the facility. So my manager just took me around to all the buildings. I got to see like test lab and the machine shop and all of the different areas. And oh, this is where the offices are. This is where you would work. So that was kind of cool to get to see all of that. And I was able to go through and kind of evaluate the company for myself too, because okay, I thought I wanted to work there, but it was good to make sure. And in the interviews, this goes for phone and the in-person one, they focused a lot on, it wasn't like hard technical questions. It was more things that are on the resume. And some of the questions became technical, but it was because I had on my resume, oh, I worked on designing these new fins for our student-built rocket. And they're, oh, what kind of challenge did you have in designing those? How did you face those challenges? And then questions like how my experience on the rocket team would fit into this project engineer role, that kind of thing. None of the questions were crazy difficult. I mean, it was still a stressful experience, as all interviews are, but it was, I think, a reasonable balance of getting to know me from what I have in a technical background and how I could apply that to a job at the company.
Thank you, Jess. It's already, believe it or not, it's already been.
Oh, it is already out.
So there's, I'm sure, still a lot that we could cover. So maybe that would be for another webinar. Thank you so much for your time.
Yeah, thanks for having me here.
Yes, I'm just going to wrap things up here. And okay, so thank you all for joining us today. Um, that was the second of a series of 3 a day in the live webinars that ASME will bring you this fall. The next webinar will be on December 4th at 1 p.m. Eastern, so about the same time. And we'll have the honor to welcome a guest speaker who works at Tesla Motors. For details on dates and registration information, please go to asme.org/a day in the life. All webinars like the previous one that we did with for Boeing, this one also will be recorded and will be available online at www.asme.org. And lastly, very important, in a few minutes, we'll send everyone here who attended and who signed up for this event but who couldn't make it, we'll send a short survey. So please be so kind and give us your feedback so we can bring you guest speakers and topics that are the most of interest to you in the future. Thank you again, and hope to see you soon on our next webinar in December. Thank you. Bye. Bye, everybody.